Hello, my name is Valery Kravchuk, and today I'm going to speak about my experience of using recent MariaDB Server version on old enough macOS operating system. I work as a principal support engineer for MariaDB Corporation, and I often have to work on different kinds of performance problems, deal with bugs, and even though MariaDB Server at the moment is not formally supported at macOS, I still would like to use the hardware I've inherited basically from my daughter who had got a new MacBook Air M1 based. So I have this MacBook, this one actually quite old, but still powerful enough, more powerful than the rest of my, here it is, than the rest of my hardware. I do not like to waste hardware. So I would like to use it as I did before 10 years ago, basically when I worked for Sun and then Oracle Corporation. I had MacBook Pro as my main working machine. I still have some remembers of the power of DTrace that I would like to use for my performance studies. I'm interested in other tools Xcode provides. So that's why I can and I would like to use this hardware. In this talk, I would like to share my experience related to building current MariaDB server versions from source on this old enough macOS High Sierra. I will speak about current formal status of macOS, some bugs, and who work on them. And finally, I'm going to present several examples of using DTrace utility, the reason basically why I am going to dive back into this software and hardware. So you should understand that macOS is formally not supported by MariaDB Corporation, neither by MariaDB Foundation, in a sense that we do not do any regular builds, we do not provide packages. There is no macOS at build board at the moment. It was not like that always. At 10.2 times, we even provided packages for macOS, but it's no longer the case. So it's not supported. Still, I found out that one of the ways to install free software on macOS, specifically MacPorts, does provide most of the versions up to 10.7 of MariaDB Server. So somebody cared to check, to build, to create something probably usable and share it inside MacPorts. Just know that by default, MariaDB Server means 5.5. And you have quite recent versions in all branches. So first thing I tried after installing MacPorts is to install different versions of MariaDB. I found out that 5.5 basically installs and works. MariaDB 10.6, on the other hand, had not installed cleanly just 2 days ago for me. So port install failed. I tried to check why in this file, it was not clear. Basically, it meant for me that there may be some problems. Maybe the old version I use, maybe the tool chain, maybe some mistakes, maybe some bugs in port, I don't know. But I am not ready to give up that fast. So I decided to continue and build myself from current source. I was a bit inspired by the fact that there are other users reporting bugs to upstream MariaDB on macOS, and of these 82 bugs, 60 were already closed, mostly as fixed. And we also have a developer in MariaDB Corporation who uses macOS for his regular work and cares about some of the bugs on recent versions at least. His name is, as far as I remember, Dmitry Shulga. So he joined from Oracle, former optimizer developer there. He's quite active in bug fixing. In the process of preparing to this talk, I found several bugs. So among these 82, there are mine as well, reported, and some of them I even fixed. This one, for example, is probably closed by the moment you are listening to this presentation. So it's a live ecosystem and it makes sense to join. Before building MariaDB from GitHub source, one has surely to install Xcode, the one that matches your macOS version. The first problem for me was that as my macOS, I upgraded it a bit, but it's still old. The latest and greatest Xcode installed, but does not work there. So I had to find out somewhere which version to install. It was 9.4 probably, point something, providing Clang 10.0. You have to decide about the tool chain for other tools for building open source software. You can build everything from source yourself, but if you care to start faster, you need to rely on some ready-to-use software. It can be either Homebrew or MacPorts. For historical reasons, I decided to proceed with MacPorts. One day, maybe I'll try with Homebrew as well. So you have to install things like Bison, make, Git, and whatever. So with and dependencies. With Git already installed, you have to clone the source code. And you should remember that for version 10.3 and newer of MariaDB, there are some modules, so make sure to update them before proceeding. I also found out hard way that by default, OpenSSL version installed on my macOS is version 3. And it's not supported by MariaDB. It was not supported until recently when this support was added. So no warranty that it works, and it does not work in some bad way in some cases. So you may have to install supported version. OpenSSL 1.1 does work. So you should also follow some same practices for building from source. For example, build out of source, create a separate directory, clean up when you switch to different branch. I would also suggest, it's suggestion to me, based on what mistake I did, to use as simple CMake command line as possible. In my case, I had at least two things to change for sure. First of all, I would like my versions to coexist, so I use different prefixes for different major versions of MariaDB. And another reason why I not switched, but decided to proceed with macOS as well, is to use DTrace there and to use all the features for DTrace we have in the source code still, specifically user-defined static DTrace probes. You have to use this define enable DTrace, and I use it in all my builds. Also, surely you have to verify the results, so find some time to run MTR test cases, test suite. With all these preconditions met and all these same practices followed, 10.1 basically builds, works, and is usable. It's not supported already, but it's a great version and I love it. When I tried to build 10.2, I hit my first problem in the client code. In readline, I found out that his entry is redefined. Somehow it started assuming that it's needed from edit line. Then as readline was installed, I did it from MacPorts. The redefinition happened and compiler complained. So I decided to fix this. I've just commented out second definition and it proceeded and worked, but I still reported a bug. 10.3. With 10.3, there was no problem with readline. It actually does not happen with any other version but 10.2. But I hit another problem with the clean build. When I tried to run MTR test, each and every test fails in one specific way. The check test case before test case does not proceed. Again, as you can see here, I reported a bug about that. You cannot really trust this build without checking, but you cannot check with MTR test cases. So you have to do something about it. I suspect that it was still about OpenSSL somehow, but I would appreciate some useful output for that. Why I think so, you will see later. So other than test cases, assuming that I do not run them, I just check myself. In 10.4 and 10.5, I've still got problems with MTR test suite. So beside that, if I decide to proceed and use MySQL install DB starting from 10.4, I get crash at this stage, very bad one. Like I have partially installed clean database with user view, for example, not created. So it's usable without grants, but otherwise it's partially installed. So before I proceeded with OpenSSL supported version, as you can see in case of 10.6, this CMake command line resolves the problem. I had to make yet another fix for 10.4 and 10.5, pointing out to proper OpenSSL just helps and works. For 10.6, there is yet another problem that I've reported elsewhere, suggested some fixes. So it turned out that Clang 10.0.0 does not support some of the assembly code go to specifically in assembly that it should support, assuming from assumptions of the creator, so probably supported on Linux, for example. So I have to add some conditional compiling depending on specifically this build of Clang. So if Apple CC is defined, I do something else like for all the versions of Clang compiler. So the problem is real, but it's resolvable. So why bother at all? Thing is, I would like to use DTrace. DTrace can be used in Linux if you use Oracle Linux. I failed to make anything usable out of patches that could be applied to Fedora, for example, yet another my testing platform. And DTrace is cool. You can find more about DTrace anywhere in Oracle documentation, from Brendan Gregg and his famous toolkits, from other parties, from the books, from Illumos manual, whatever. A good thing with macOS is the trace is there, so you can just call it, and if you know how to use it, you can apply it. For those who follow me in Linux world, I am a big fan of BPF trace on Linux, and BPF trace is modeled after DTrace. Syntax is very close. It's still similar to C and AWK languages. Basically, you set up probes, and for each probe, you can set up, when it's hit, a sequence of actions. So like that. It's a bit more complicated than BPF trace, but still usable. So what features of DTrace I suggest you to use? First of all, with the way I build from source, you can use user-defined static DTrace probes or static trace points, and there are several in MariaDB with specific names like query start, query end, and whatever. So for some of them, you can actually find examples of how to use them in the source code of MariaDB itself. For example, if you will search for query start, you will see an example deprogram query time. And it's a lightweight slow query log. For each SQL statement, there is a way to record on the fly time to execute it completely from the beginning to end. And in this query time part file example, part of support files for DTrace, you can see how it's done. Basically, I removed some copyright notice, a bit simplification, and different formatting was added. Basically, the program is like that. There is a begin probe like an AWK, so it prints some title. Then, whenever query start probe is hit in MySQL, note it's still MySQL. Do not use MariaDB here. Nobody changed the probes for MariaDB from those in MySQL 5.6 that we inherited and still keep. So we remember the text of the query, basically that, and when it started and when it ends, we print the query itself, thread that started it, it's who, which database the query is running against, and we print time in milliseconds, as far as I remember, to get some useful output. Besides static probes, you probably, again, if you follow me, you know that I'm a big fan of dynamic tracing. So My idea is that with BPF trace, with Linux dynamic tracing tools, with some impact surely and some problems, I can add dynamic probe, some action that is triggered whenever we hit every other line in the code. At least it's really easy to do, even with perf for quite more than 10 years already in Linux, whenever you enter the function and exit from the function. So one of the first things I want to remember, recall, or find out about DTrace is how to repeat this. So how to add user probes for specific functions. And I found out that it's really easy. Consider this simple D program, user func point D, that will show in indented way. So it's like a tree of calls. Entry, it's entered to specific function. Return, it's return from specific functions. I do not care yet. I do not know yet. I don't remember yet how to present arguments of functions, how to deal with return value, but at least I can trace everything dynamically. So with such a simple program, I've decided to trace every function in the process that is actually MariaDB on my macOS, every function because I have a star here, and trace everything while running, I don't remember, probably a simple load, not a sysbench, traced every function, and it worked. And I had more than 450,000 probes. So these are a number of different functions. With BPF trace in current MariaDB code, I have less than 40, as far as I remember. Yes, surely less than 40,000 potentially probable functions on Linux. And when I tried to do a test coverage check with BPF trace on Linux, it failed miserably on my hardware with that many probes. Here it just works. It creates a big enough file of 4 megabytes over a short enough period of time, but I can trace everything. Moreover, while at Linux land, there are different projects that are work in progress on how to represent graphically the results of such tracing. The entire instruments tool that is part of Xtrace with its tracing abilities is built up based on DTrace and allows you to record run of the entire system or specific program for any period of time that you care about, and then replay and study it at each and every stage. I am just a lame user of instruments for a couple of days, but I've already started to use it against MariaDB, and I see some promising results. In any case, I am also able to add my own DTrace probe so I can record whatever I need and still use this ability of graphical user interfaces on top. I'm really excited about this part. So to summarize, what's next? I have to recall and study DTrace internals, re-implement and recheck all Linux BPF trace scripts I have. And from what I see that DTrace scales better, I have huge hopes that the impact may be smaller, or I can use more probes, or I can trace more log calls maybe specifically with such a simple tool. I also need a tool chain, and I already have it. I have run in sysbench and everything built from sources. The idea is to study some of my MariaDB server performance problems I hit in my practice on macOS, where we seem to have a good enough or maybe better instrumentation than on any Linux. I started to provide patches for some of the bugs that I reported. I'm going to report more with 10.7. There is yet another bug that I'm not yet seen, found, not yet fixed, so it's not yet reported. I'm going to upgrade my macOS and maybe hit something new or resolve some problems easier. So that's what I'm going to speak and write about in upcoming months this year. And my eventual goal, performance-wise, is to get my hands on some newer Apple hardware based on M1 or maybe M2 chip and run tests at scale. For now, I'm just preparing to that. So that's all from me today. I'm ready to your questions. If you hit a bug in MariaDB, do what I did, report it to MariaDB Jira. Thank you for your attention. Bye.